All right. So the distance between the x's is 0. The distance between the y's is 1. So as I said, if you show me the actual subtracting with the parentheses and everything, that's fine. You have to show me at least the minimum of this. So the distance of those 2 points between those 2 points is a 1. Okay. The midpoint, you take the square root of 2 plus the square root of 2 over 2 for your x, and 4 plus 5 over 2 for your y. You do need to reduce any fraction or anything, radicals, anything like that that can be reduced, you need to reduce. All right, is that okay with everybody? I'm going to take 6 points off because every 4th grader American has to reduce fractions. I'm pretty sure you should be held at the same standard. It'll be a reducing point. Yeah, you don't want to rack those up. Okay, number 20 there. This example has a lot of letters, so I would go ahead and do the formula to make sure of what we're doing. So we've got v minus w minus v plus w. Those are our x's subtracted. T minus t. Okay, so you're subtracting the x's and squaring it, subtracting the y's and squaring it. So when I subtract these x's, I'm going to distribute that negative sign. What does it actually equal here? The v's do what? They cancel. So we would have a negative 2w squared. This is 0, so that's nice. What does negative 2w squared to 4w? Do you understand why I do not want you to say, oh, the square root of the square cancels that and leaves you with negative 2w? Because you can't have a negative distance, can you? No. So at this point, when you take the square root, you get a positive 2w. Okay? Not have a negative distance. All right. Midpoint, we are adding the 2 x's. We're adding the 2 y's. So that's 2v over 2, 2t over 2. vt is your midpoint. Okay, because the w's are going to cancel. Make sense? All right, so we have a slope, we have a point. So we're going to use point slope form to start. So it's y minus the y of the point, slope times x minus the x in the point. You distribute, and then get the y by itself. Nothing crazy? Okay. In the second example, what do we have to do first? Find the slope. So the slope is a negative. And again, if you want to do that with a little shortcut, you should be able to write the slope down without any work. But if you show your work, I'm okay with that. pick a point. It doesn't matter which point. I'm going to pick the first one. So it's going to be y minus a negative 3, negative 6, 7, x minus a negative 1. Now again, you have no calculator, so you've got to be able to subtract 3. What's our common denominator? How do you make a 3 out of something divided by 7? 21 over 7, right? So we're going to make this a 21 over 7. So you get negative 6, 7x minus 27 over 7. And then that would be your final answer. Okay, if it's respect to the x-axis, what do you do? Make the y negative. Okay. So, what am I doing? There's only one y, so that's nice. Our goal here is to see, does it equal the original? So we're going to get the y by itself. We're going to distribute that negative to the right side. Does that equal the original we started with? No, so it is not symmetric to the x-axis. And then you're going to do the y-axis. And before anyone asks me, do we have to show all that work? Yeah, you do. Because that's what we're in. We're in work class. So we're going to plug in a negative x. Okay. All the even exponents that I see are going to bounce those negatives. So does it look like the original? Yes, so yes, this is symmetric to the y-axis. And the last test we're going to do is the origin. So we're going to change both the x and the y. So you've got to evaluate your exponents first. Then distribute the negative from the left side. And that is once again a no. Okay. You see now? We could do that. Yep. Let's try this guy. So again, we're going to do the x-axis. We're just changing the y. So the first part bounces back to the original, but the second part does not. So that is a nope. The y-axis, x is going to be negative. And that's a nope. And the origin, and the origin's a yes. There's a double negative there, flips it. Here you go. What's our restriction with number 44? What's not allowed here? negatives in the denominator, or in this radical, yes, and 0. The bottom can't go to 0, right? So normally we would say this restriction for the square root would be greater than or equal to 0, but we're not going to put or equal to 0, right? It can't be 0 on the bottom. So we're going to leave it just as greater than. So pay attention to where that radical is. If it's in the denominator, 0 is not allowed either, okay? I'm just going to move the x to the right. So x has to be less than 4. Please check your domain. Sometimes you switch the alligator mouth when you're not supposed to, right? Check it. If I put in something greater than 4, let's try 5, would that work? 4 minus 5 gives me a negative. That doesn't work. So just test it real quick. Okay? So that would be your domain. In the second one, we have a radical in the top and we have a bottom. So I'm going to do the radical on the top first. It's got to be greater than or equal to 0, and the bottom has to be not equal to 0. Okay? So if we start solving this algebraically for the numerator there, I get x squared has to be greater than or equal to negative 1. Isn't that always true? Can we take the square root of a negative 1? No. So when you get to this point, you can't solve it. That basically is saying this restriction is not needed. X squared plus 1 is always positive. It can't be negative. So we don't have to worry about it. So all we have to worry about is x cannot equal to 0. Okay. X squared plus 1 has to be 1 or higher. It cannot be negative. So that restriction is not really a restriction. Okay. So I would practice those more from that page. Yeah, that one bothers me. All right. So they're giving you two x values. Understand. Doesn't matter if those are called a's or b's. A is the first x, b is the second x. You're going to plug those into the function and get your corresponding y value. Okay, so the second one's 4. And then since they want the average rate of change, they want you to find the slope between those 2 points. Okay? So if I'm wanting the slope, it's going to be second y minus the first y over second x minus the first x. So again, we have a fraction here. You've got to be able to add and subtract fractions. If I would write 4 with a common denominator of 7, that's going to be a 28 over 7. Okay. So 4 minus 28 over 7 is negative 24 over 7, and on the bottom we're going to have a 6. How do you reduce that? How do you divide a fraction by 6? Yeah, multiply by the reciprocal. What's the reciprocal of 6? 1/6. Yes, 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 you must be able to reduce that. 6 goes into both of them. So you're left with negative 4/7. If it is even, it should match the function we are given. And I'm going to write it here so we aren't confused. Okay? Let's move with that. Okay. If it is odd, it's going to be the opposite of the function we were given. And remember, if it's opposite, it either changes the top or the bottom. Okay, it doesn't change both. So we're going to multiply the top. Let's multiply the top by negative 1. So that changes that numerator. Okay, so that's what we have to match. So we are going to plug in a negative x and see where we are. So we have negative x cubed plus 2 times negative x all over 2 times negative x to the 5th minus 3 times negative x. We have all odd exponents, so all those negatives are going to stay and get pulled out in front of each term. Negative and a negative there is a positive. So it doesn't look like an even function, and it doesn't look like an odd function. But before you decide that it's neither, I would like you to change everybody's sign. So what I'm doing here in actuality is I am multiplying the top by -1 and the bottom by -1. We're allowed to do that because that's technically 1, yes? -1 over -1. So we're going to change everybody's sign, basically. Now, given that simplified, switched around guy, does he match an even or an odd? He's even, yes? So before you say neither, go ahead and multiply a negative to the top and the bottom. Change them both, change them all, and make sure that he doesn't match either, okay? Because sometimes it's hiding there. Okay. So this next one, we are going to, again, the even guy looks like the original. And the odd guy looks like the opposite. And again, the opposite, I'm just changing the numerator. You're only distributing one -1. And then we're going to plug in a negative x. So our negative x squared is going to be x squared. Negative times negative is a positive. Negative x to the 4th cancels, and we're sitting here. And I look, and it does not match my even. It does not match my odd. If I switched everybody's sign, top and bottom, it still would not match either of those, correct? So this is a neither. Okay? That makes sense? Okay, to find the x-intercepts, I am plugging in a 0 for the y. So all the y things cancel, and we just have x equals 1. Because the cube root of 1 is still 1. To find the y-intercepts, we're going to do the reverse. We're going to plug anything with an x. Make it a 0. So again, all these x things are going to cancel, and you're left with y cubed equals 1. So y equals 1. Okay, and if you want to write those as points, plug in 0 for the other guy's variable. All right, so the first one, let's just do the A one first, the g function. So what does this -1 do? Moves it to the right one. And what does this +2 do? Up 2. Okay. And then they have a separate equation, h. So we're looking outside. Multiplying by 3 outside would be a vertical stretch because it's greater than 1. Remember, when it's inside, that would be a reciprocal. So you wouldn't think 3, you'd think 1/3. Okay? And then the minus 1 outside is going to make it go down 1. All right. On the other side, our g function. Before I do anything with this g function, notice the x is being multiplied. I'm going to rewrite the g function by a -1. So anytime the x is being multiplied by something, I want to factor it out. So I'm factoring out a -1, and that gives me an x minus 1 inside. It flips that guy. Okay? So the 2 outside is a vertical stretch by 2. The plus 4 outside is up 4. So those are both vertical things. If you go inside, you're going to do the minus 1 or negative, whichever one you want to think of it as, a what? Reflection over the y-axis. And the minus 1 in here is a right one. Does that make sense? You have to just factor out that whatever it is, whether it's a negative or just a number, you just have to factor it out. Okay. H, we have a negative out front, which is a reflection over the x-axis. We have a plus 3 in the back, which means it's going up 3. Those are our vertical things. And then we have a minus 1, which means it's moving to the right one. Right? So there's other examples. You saw all those other practice ones. Practice a couple more tonight. Make sure you know what you're doing. Look through the different reviews that are on there. There's one for every period. If the answer to a question that you did is not on there, shoot me a text and I will send you. Okay? We're good?